All right, so for everybody's favorite topic, we are going to be factoring today. In order to start factoring, we're going to start by going backwards. So this is the factored form of an equation. We are going to unfactor it, aka we're going to distribute. You might have heard this called the FOIL method. I call it double distribution. So we are going to make sure that as we are multiplying these guys, that my first term multiplies to the first term of the second binomial, 2y squared. It multiplies to the second term of the second binomial, 4y. And I have to make sure that I do the same thing for the second term in my first binomial. So negative 3 times y and negative 3 times 2. Oops. There we go. To finish it off, we combine like terms. So that 4y and that negative 3y can combine. 2y squared plus y minus 6. That would be the unfactored form of that trinomial. Questions on that? We've seen this before, yes? Fantastic. So if we can distribute by figuring out those terms, the first two terms multiplied together, if we use FOIL, outsides together, insides together, last ones together, then we can do the same thing, but backwards to factor. I'm not sure how you guys learn to factor, but the way that I do it in my class, in all of my classes, is called the guess and check method. And that's literally what we're going to do here. For the guess and check method, the steps are pretty straightforward. We look at the first term, which in this case is x squared. And I think, okay, what things multiply together to get x squared? I only have one option. The only way to get x squared is to multiply x times x. So I can go ahead and put those first in my bubbles, in my parentheses. Then I look at the last term, which is 12. And I do the same thing. I figure out, okay, what terms or what factors multiply to 12? I got a couple options. I have 1 and 12, 2 and 6, and 3 and 4. I'm not going to pay attention to the sign yet, but the sign will come into play in a second. And now this is where I guess and I check. I look at those options. In my head, I know that when I factor, they have to multiply together to get that 12, but add together to get that 7 in the middle. So if I'm guessing and checking, I'm going to guess it's probably going to be 3 and 4 that end up multiplying to that 7. So that's what I'm going to guess. And now I check the same way that I did this problem up here by distributing out those terms and making sure that I get what I had originally. So I know that x and x makes x squared. I know that 3 and x makes 3x. I know 4 and x makes 4x. And I know that 3 and 4 makes 12. And I know that when I combine like terms, this 4x and this 3x will combine to 7x. That's the guess and check method. It can get a little bit trickier when we have more complicated trinomials, but this is essentially it. Any questions on that? Okay, let's keep looking through then. So again, I'm going to use this guess and check method. I start always with that first term, which for me is x squared. And just like in that last one, the only two things that make x squared are x times x. That's the only way we can get there. Now, how about my last term? How am I going to get 20? What are my factors of 20?
1 and 2, 3 and 4, 5 and 4.
Perfect. Now I'm going to guess and check. I know that I want those numbers to multiply to 20 and add to 8. Here is where I can start paying attention to that sign. If I'm multiplying to a negative 20, what's the only way I can multiply two numbers and get a negative? a negative and a positive. So I know that one of these is going to be a positive, one of these is going to be a negative. We're going to guess. I'm trying to add up to 8 there. So what's our guess going to be? Probably 2 and 10. We want which one to be negative if I want a positive 8? Yeah, I'm going to want the 2 to be negative and that 10 to be positive. And then again, I check my work. So x times x, x squared, 10 times x, 10x, negative 2 times x, negative 2x, and then negative 20. These two combine to positive 8x. And that's the guess and check method. Questions on that? Okay, our quadratics, though, are not solved yet. They are factored, but they haven't actually been solved. In order to solve a factored quadratic, we use what we call the zero product property, or ZPP for short. Okay, the zero product property says I set my equation equal to 0. That is really important that your equation says equal to 0. I'm going to be looking for that in your notation. Once our equation is equal to 0, then we factor it. Then we can say, well, some of those factors by the zero product property must be equal to 0. So I set each factor individually equal to 0, and I get my answers. So for example, let's use the same equation that we just did. So I know that those factors, are going to be, how did I get so far away? X plus 10 and x minus 2. I got that equals 0 in there because I need it for notation. And now I take each piece that contains an x and I set it equal to 0. So x plus 10 equals 0 and x minus 2 equals 0. And I just do the 1 or 2 steps that it takes to solve for x. So I got 2 answers. Questions about that? The last thing that we're going to do here is we're going to sketch what this looks like. If you remember, a quadratic is going to take the form of a parabola. Where are these solutions on my parabola? Do we remember? On my graph, where do those go? Anybody? Another name for them is zeros or roots because they go on the x-axis. They are the x-intercepts. So I'm going to go ahead and put negative 10 on my graph. I'm going to put 2 on my graph. And then, do we know how a parabola opens? Is it going to open up or down? Any ideas? This parabola is going to open up because my first term is positive. So that means it's going to open this way. And that's all we need for a sketch, is to sketch our solutions and make sure our parabola is opening the right way. Questions there? When we are doing our sketches, we kind of have 3 options for what our graph might look like. It could look pretty much exactly like that one we just did. There are 2 solutions, so we have 2 x-intercepts. Sometimes we might get no solution, meaning our parabola never crosses that x-axis. In that case, we would have no solutions. The last option is if we get 1 solution, and that looks like my parabola touches my x-axis exactly 1 time at the vertex. Questions there? Flip it over. We got a couple more examples we're going to do. Things start to get a little bit tricky when we get into more complicated trinomials. So in number 1, let's go through some steps here. The first thing that I always need when I am solving these quadratics is that equals 0? Because for zero product property, our equation has to be equal to 0. Ooh. So step 1, set equal to 0. That means I'm going to move that 3 over to the other side by subtraction. And actually, both of those are going to cancel out. I'm left with 7k squared minus 6k equals 0. After that, do we know what we need to look for in this equation? What do we look for? Trying to simplify this equation the best I can. What can I take out of it? What can I take out? Casper, do you know? Yeah, we can take out a k out of everything. This is called taking out the GCF. So, greatest common factor. That is what I am looking for. In this case, my GCF, the only thing we can take out of both of these terms is a k. When I take out a GCF, I leave it to the side. It is still part of my equation. I just am taking it out to the side. And then I divide everything by that GCF. So 7k squared divided by k gives me 7k. Negative 6k divided by k gives me negative 6. And I am not going to forget that equals 0. It's still with me. Now this is the step where I would factor. This is not anything that is factorable anymore. I've taken everything out. I'm just left with a k and a k. So this technically is the factored form. So we can skip that step. And we're going to go straight to the last step, which is ZPP. Okay, ZPP says I set each piece that has a k equal to 0. So this guy, k equals 0. This guy, 7k minus 6 equals 0. And I got 2 solutions. Let's really quickly graph that. It's positive, so I know that my parabola is going to open up. There's my roots. And we're good. Any questions on this? Next one, again, kind of tricky. We're going to go with that first step, which is to get everything set equal to 0. So now I'm going to add 3. I'm going to change colors here. I have 6b squared minus 13b plus 6 equals 0. That's step 1. Step 2, I look for a GCF. Is there anything that I can take out of all of these 3? No. I can't divide 13 by anything. I can't take out any b's because there's no b in the last term. So I'm done. The next step now is to factor. I always start with my 2 bubbles. 2 bubbles of parentheses. Don't forget that equals 0. I'm going to find factors of my first term, and then factors of my last term. How can I get 6b squared? There's 2 different ways that I can multiply together to get 6b squared. What are they? Casper? 3b and 2b. And what's the other one? Perfect. So I have 2 options. The first part of my parentheses here is either going to be 3b and 2b, or it's going to be b and 6b. And I don't know which one I'm going to use yet. So I go over to the last term, and I'm going to do the same thing. So factors of 6, 1 and 6, 2 and 3. So I have 2 options for my first term, 2 options for my second term. I'm going to have to do a little bit of guess and checking here. Let me show you a secret to help us narrow down our options. Let's say I'm not a good guesser, And I pick this guy right here, 6b and b. Let's put it in. Now I need to guess the second part. So I'm going to pick, I don't know what order I'm going to put them in, but I'm going to pick 2 and 3. Here's a secret. If one of my bubbles has a GCF, then it is not the correct pairing of things. So do we see how this bubble on the left has a GCF of 2? I know that that doesn't work. Let's flip it around. Maybe 2 doesn't work. Can I put the 3 in here? No. So I know that that's not going to work for 2 and 3 are not going to work for 6 and b. So I try again. Can I put the 6 in here? No. Okay, that would have a GCF of 6. So my only option was I could put the 1 and the 6 in here. That has no GCFs. So let's check if that works. So now I'm going to do the inside-outside test. I'm going to multiply these guys together to get b. I'm going to multiply these guys together to get 36b. Does that add up to negative 13? No. Clearly, we can see that it's way too big. So I'm not even going to go any further. I'm going to erase that. I've basically eliminated all of my options for 6b and b. Now, maybe you're a better guesser than I am, and you selected 2b and 3b from the start. Fantastic. We can already eliminate. I know I can't do 2 and 3 in that order because that would have GCFs. I know there's nowhere I can put that 6 because it would have GCFs. So that's done. My only option is 3. Let's change colors. Is the 3 first and then the 2. So I know that's long-winded. If you know this stuff, you can get it really fast. If you don't, there's your secret for how to eliminate some options. So I want a negative 13b. So when I multiply together, I get 9b and 4b. The only way I'm going to get a negative 13 is if both of those numbers are negative. And we're good. Now I'm going to erase some of my work here. And I'm going to finish it off using ZPP. Set each guy equal to 0. I have b equals 3/2 and b equals 2/3. And I'm going to sketch it really fast. 2/3, 3/2. My equation, my original equation, had a positive leading coefficient, so I know that this is going to face upwards. Any questions on that? I'm going to do one more, and then we're going to skip the last one. We're ready for the last guy here. This one gets a little bit tricky. This is a cubic, not a quadratic, so I have an x to the 3rd in here. We're basically doing the same thing. It just gets a little weird at the end. So the first thing that I do is I make sure that it's set equal to 0. Oh, hello. Then I'm going to take out any GCFs that I see. What's the GCF of this equation? Casper. Not just an x, I can also take out something else. Yeah, I can take out a 7x. So I'm going to divide all of these terms by 7x. I'm going to have 3x squared. I'm going to have negative 11x and negative 4. Questions there? Now when I start to factor, I'm going to drop everything down, so I don't want to lose track of that 7x. And I'm going to do the same thing that I've been doing before. My first step is to look at factors of that first term. There's only one way we can multiply to 3x squared, and it's 3x times x. There's a couple of ways we can get 4. That's 4 and 1, or 2 and 2. And I'm trying to add up to 11. So what are we going to guess? Go ahead, Casper.
4 and 1.
Yeah, 4 and 1. Do I want the 4 to be on the left bubble or the right bubble?
No, left.
If I put it on the left bubble, it's going to multiply to this x, so let's try it. That gives me 4x. That gives me 3x. Does that add to 11? No, so let's flip them. Let's do 1 and 4. This way, I get x and 12x. Is that going to add up to 11? Yeah. I want a negative 11, so I want the 12 to be negative. Oh, hello. I want the 12 to be negative, and I want the x to be positive. How did I do that? Questions on how we factored that? Now I need to use ZPP. So I'm not going to forget to actually solve this. I'm going to set these guys equal to 0, because those are the ones in my bubbles. But I'm not going to forget, if I have an x over here on the outside, this also gets set equal to 0. If it was just a 7, we don't have to do that. But because there's an x there, it is a factor that we're going to use for ZPP. So my answers are x equals 0, x equals negative 1/3, and x equals 4. I'm going to sketch this. This is not one that you are going to be expected to sketch on like a test or a quiz, but it is kind of useful to know. I got negative 1/3, I got 0, and I have 4. This cubic will look like this. Something crazy like that. All right, that's it. Any questions?